Now let us solve other problem. A uniform stretched string of length L and the initial velocity of the string is given as V0 between L/4 to 3L/4. So we have a string which is the length, which is having the length as L. Initial velocity lies somewhere here. So initial velocity, which is nothing but, which is in between L/4, which is nothing but V0, lies between L/4 to L/4 and 3L/4. Okay. Now, while the string is in its equilibrium position, find the displacement. So we are going to find out y of x comma t. Similar problem. So this is the wave equation, and y is the function of x comma t. We are going to find out. So this is the condition, and we know about the boundary conditions earlier, which we learnt earlier. So these are the boundary conditions. There are no equations are given, so that's why it's written as 0 here. Last time in the problem there were some equations, correct? So here there was no equation here, so that's why it is termed as 0. So it is termed as 0 here, and we have to differentiate. Okay, differentiate with respect to t, and equate to 0. So this is your boundary conditions. So we have to apply boundary conditions one by one, and this is a condition given in the problem. So we have now 0 to L/4. So between x lies between 0 to L/4 is nothing but 0. Between this interval L/4 to 3L/4, it is V0. It is given as V0. The last one 3L/4. See, x lies between 3L/4 and 0. Again it is 0. So we have to use these conditions also. Okay. Now we will go for the first condition. The general solution is given by this equation A. Okay. Now we have to use the first condition. So this is your first condition, x equal to 0. Y of x comma t. First condition is x equal to 0. See here, x equal to 0. So x equal to 0. So you have to substitute x equal to 0 here. Here x equal to 0. Here x equal to 0. It contains only t. It contains also t. So x equal to 0, that will give you. This will become 0. So this will be alone a. So a times this expression. So it implies that a equal to 0. Similar thing. Second one is, so y of x comma t. So we know equation a becomes, instead of a, we have to write 0 here, and this equation becomes exactly like this. Now second condition, look at the second condition, y of L comma t, because the string length is L. So instead of x, you have to substitute L. So instead of x, you have to substitute L. So b sin PL, this becomes PL. Okay, b sin PL times c cos PAT d sin PAT, which is equal to 0. So as we have seen earlier, b cannot be equal to 0. We have already set earlier. So sin PL equal to 0, which is equal to sin n pi. So PL equal to n pi. P equals n pi by L. So you have to substitute for P. You have to substitute n pi by L. Okay. So this becomes exactly like this. So we are going to substitute. Instead of P, we will have to substitute n pi by L. Okay. So this is equation 3. Now let us apply the third condition. Third condition is t equal to 0. Third condition is t equal to 0. So when it goes like this, we have t equal to 0 implies that this cos 0 is 1. So we have c times 1. This becomes 0. So c plus 0 times b sin n pi x by L. So it implies that c equal to 0. It implies that c equal to 0. Correct? Because b, already we said that b should not be equal to 0. B cannot be equal to 0. So c equal to 0. Okay. Now substituting c equal to 0 in equation A. So this is equation A. So we have only two terms now. So b sin n pi x by L, d sin n pi at by L. Now this is the equation, same equation. Now you just differentiate with respect to t. So that will give me with respect to t. So that will give me this equation. So we have bn. We will have to differentiate this with respect to t. That will give us n pi a by L. See, n pi a by L times bn. Other things and all let it be. So we will have to differentiate this. That will give me cos. Okay. Now I am going to keep bn n pi a by L, which is nothing but your bn. I am going to keep. Okay. So this is one constant. This is another constant. I am going to keep this as small bn. Okay. So this becomes this becomes small bn sin n pi x by L, which is equal to the condition given in the problem. See, this is the condition given in the problem. So this is the condition. So there are three limits. See here, there are three limits. Here we have 0 to L. 0 to L. So we are going to divide the length 0 to L into three sections. One is 0 to L by 4, another one is 4 by L to 3L by 4, 3L by 4 to L. So your Bn, we are going to find out Bn, 2 by L, 0 to L. We are going to use half range Fourier series. Can you remember this is half range Fourier series? F of x sin n pi x by L dx. So as I said earlier, we are going to have three limits. 0 to L by 4 is first one, L by 4 to 3L by 4, 3L by 4 to L. And of course we know in this interval this is 0. In this interval this is also 0. So only middle alone exists. Only this alone exists. Which is nothing but your f of x is nothing but your f of x. This is nothing but your f of x is nothing but v naught. So your v naught. You pull constants 2v naught out, 2v naught by L, and we are going to integrate this one. Integration is very simple. So integration that will give me minus cos n pi x by L divided by n pi by L. This L and this L will cancel. 2v naught divided by n pi. So 2v naught divided by n pi. Remaining term is like this. And we are going to substitute the upper limit for x. This will give me this minus, already one minus is there, so this will become plus. So we have cos n pi by 4. Is it okay? Now 3 instead of x we are going to substitute 3L by 4, correct? 3L by 4. This L and this L will be cancelled. So we have 3n pi by 4 minus cos 3n pi by 4 is nothing but cos n pi by 4. So you have to remember. And cos n pi by 4 can be written as cos n pi minus n pi by 4. Now you can expand this one. Cos A minus cos B. You can expand. Cos A cos B plus sin A sin B. You have to use that formula. So according to this formula, you have this expression, and of course sin n pi is 0. So this term, third term will go off. Will get cancelled. We have only these two terms. And we know cos n pi 4 is as it is written. Cos n pi is nothing but minus 1 to the power n, which you have already learnt earlier. Minus 1 to the power n. And we have the common terms. Cos n pi by 4 is common. I have pulled out. And remaining term will be 1 minus 1 to the power n. Is it okay? Simple one. Now I have written the same thing here. Now, as usual, when n is odd, when n is odd, minus 1 to the power 1, which is nothing but minus 1. So this becomes 1 minus of minus 1 is nothing but 2. Although 2 is there, so this becomes 4. When n is odd, this becomes 4 times v naught cos n pi by 4 divided by n pi. Whereas when n is even, n equals to 2. So minus 1 squared plus 1. So we have 1 minus 1 becomes 0. So 0 when n is even. For all the even numbers we have 0. For all the odd numbers we have this value. So we have found out now Bn. Actually capital Bn is Bn divided by n pi by an. So your instead of Bn you substitute here. So this is your Bn. Original Bn in the Fourier series. Half range Fourier series. So we have the complete expression for your wave function, which is nothing but y of x comma t, which is equal to summation over n equal to 1 to infinity 4 v naught L cos n pi by 4 n squared pi squared a sin n pi x by L sin n pi a t by L. So this is the complete expression for your wave function for the problem. Now we will solve another boundary value problem. The similar method, very simple, similar method. So we let us solve this one. Now it is given as d squared y by dt squared, which is equal to 4 d squared y by dx squared. So it is given as 4 instead of a squared or c squared, which you have seen earlier in the problems. So instead of 4, instead of a squared, it is given as 4. So a squared is nothing but 4. So in earlier problems we have only c squared or a squared, but this time it is given as 4. So your a squared is nothing but 4 or c squared is nothing but your 4. What are the boundary conditions? So this is the boundary condition as it is given in the problem. It is in the problem. We are going to find out the displacement of the string. We are going to find out y of x comma t as usual. So we have now boundary conditions. So this is our first boundary condition. y of 0 comma t is equal to 0. This is our first boundary condition. The next boundary condition is y of 10 comma t. Your instead of x, it is written as 10. So earlier in the problem, it's written as x equal to L. Can you remember? X equal to L. It was written as y of L comma t in the earlier problems. Now it's written as 10 comma t. So L is 10. So this is our second boundary condition. And third one is y of x comma 0, that is t equal to 0 equal to 0. And differentiation. Answer is with respect to t. Answer is 3 sin 2 pi x minus 2 sin pi x. It is given in the problem. This is your f of x. Using this, we are going to find out y of x comma t. So that's the idea. So in earlier problem, it was given as a squared, it was given as L. Okay. And we are going to find out the displacement of the string, which is nothing but y of x comma t. So now instead of 4, I have written as a squared. See a squared. So a equal to 2. And of course L is given as 10 in the problem. See L is given as 10 in the problem. So we have L equal to 10. What are the boundary conditions? This is the boundary conditions which are there in the problem. We already discussed. So we have to find out the first solution. So we should know the solution, which is given by equation 1. So these are the conditions. These are the equation. Okay, don't get confused with this one and this one. Okay, so we have y of x comma t is this equation. This is the solution of this equation, this partial differential equation. Now as usual, you have to substitute condition 1. Condition 1 is x equal to 0. X equal to 0 in this equation you have to substitute. So this becomes exactly y of x comma t, x equal to 0. Y of 0 comma t, which is equal to a c cos pat, because we know x equal to 0 will give us, this is 0, this is 1, so a times, cos pat plus d sin pat, so it implies that a equal to 0. So substituting a equal to 0 in equation 1 will give us this. Now we have to substitute condition 2, condition in equation 3. So this is equation 3. What is the condition? X equal to L. So wherever you find x equal to, so x you have to substitute L. Okay. So this becomes sin we have written as sin PL. Can you remember? So wherever you find this, so this becomes PL. Okay. So this becomes sin PL. There's a mistake here. So instead of x you have to substitute L. So this becomes PL. So b sin PL, which is equal to 0. So b sin PL, which is equal to sin n pi. So there's a mistake here. I repeat, see here, b sin PL, which is equal to 0, which is equal to sin n pi. So your PL equal to n pi. P equal to n pi by L. Now substitute for P, you can substitute for n pi by L. That will give us b sin n pi x by L. See, b sin n pi x by L. Cos n pi at by L, d sin n pi at by L. Now we will substitute condition third. Condition third is t equal to 0. So t equal to 0 and this term will go off, t equal to 0. See, we have sin 0 is 0. This term alone will exist. So we have this term alone. B cannot be equal to 0 and C only possibility C equal to 0. Substitute, we will have y of x comma t is in this equation. Now you will have to use, as I said, you will have to use only half range Fourier series. So this is your bn sin times sin n pi x by L, sin n pi at by L. So you have to find out now bn. Substitute in this expression. So that is your complete wave equation. So before that, we will have to have the partial differential equation with respect to t. So that will give us bn n pi by al. We will have to differentiate this. So that will give us n pi a t by l. So n pi a by l, and sine becomes cos. We will have to differentiate sine. So that will become cos. So cos n pi a t by l. Substitute t equal to 0. This term will go off. So we have only these two terms. bn n pi a by l sin n pi x by l. This is equivalent to given in the problem. This is for f of x. So this is this is equal to 3 sin 2 pi x minus 2 sin 5 pi x. So this is okay. This is given in the problem. So I have written the same thing here. And now substitute, instead of n, you just substitute 1. So this becomes b1. Instead of n, you have to substitute 1. So this becomes pi a by L is 10. So 10 I have written. Sin n, instead of n, substitute 1. So sin pi x by 10. Plus substitute now 2. So b2, 2 pi a by 10, 2 pi x by 10. Correct? Now instead of x, you just substitute 20. Dot 20. So this becomes b20. This becomes 20 pi a by 10. Only we have 2. So we have 2. 2 pi a. Is it okay? Now instead of x, you have to substitute 20. Instead of L, you have to substitute 10. So we have sin 2 pi x. Is it okay? Plus b50. Instead of n, you have to substitute 50. So this becomes b50. 50 divided by 10, which is nothing but 5. So 5. 5 pi a sin 5a, which is equal to this. Now, compare the coefficients now. You just compare the coefficients. We can compare the coefficients only with this one and this one. See, here we have sin 2 pi x. We have sin 2 pi x. And here it is sin 5 pi x. See, sin 5x. We can compare only these two. Other all the coefficients will become 0. See, only these two coefficients exist. You compare the coefficients on right hand side and left hand side. This coefficient, see, this coefficient, they are equal. And this coefficient also there. All the other coefficients will become 0. So b1 equal to 0, b2 equal to 0, b3 equal to 0. Only b20 exists and b50 alone exists. Only two coefficients exist. So we have b20 2 pi a, which is equal to 3, which is equal to 3. So b20 equal to 3 divided by 2 pi a. Similarly, you can go for next one. You will have to compare this one. So b50 5 pi a, which is equal to minus 2 is here. Minus is here. So minus 2. So b50 will be minus 2 divided by 5 pi a. Now, so method of general solution is given by this, and we can expand this one. We can expand this one, and instead of b20, you substitute 3 divided by 2 pi a. Instead of b50, you have to substitute minus 2 divided by 5 pi a. That is given as a equal to t. Can you remember? This is what we replaced. So instead of a, you have to substitute 2. So that will become exactly this equation. So this is your complete wave equation. Y of x comma t equals 3 divided by 4 pi sin 2 pi x sin 4 pi t minus, this is your b50. So 2 divided by 10 pi sin 5 pi x sin, instead of a, you have to substitute 2. So 10 pi t. So this is your complete wave equation for the problem. Okay, we'll stop today.